So we're going to consider two more cases. So let's assume we're given the rational function p of x divided to the r of x, right? So the ratio of the two polynomials. And in order to integrate this, first of all, we need to rewrite this. We need to rewrite its denominator as the multiplication of the linear factors, right? So this is what we did before. So now, the case 2 is where the r of x can be written as a multiplication of the linear factors, where some of them are repeated. Okay? So let's consider this case. So let's say I would like to integrate for x divided to the x cubed minus x squared minus x plus 1. Okay? So in order to integrate this, first of all, we need to write down its denominator as a multiplication of the linear factors, right? Basically, we need to find all the roots of the denominator. So in order to do this, let me take out the x squared from the first two terms. If you take out the x squared, what you have? X minus 1. And let me take out the minus 1 from the last two terms. What you will have? X minus 1, right? Yes? So now let me take x minus 1 and x minus 1. So this is equal to x cubed minus x squared minus x plus 1. Let me take out x minus 1. What you will have? X squared minus 1, right? So let us further factorize this. It will be x minus 1, x minus 1, x plus 1, right? So basically, I found the linearization or like a linear factorization of its denominator. Right? So I wrote down the denominator as the multiplication of the linear factors, right? Or linear functions, where some of them are repeated. You see? So this one is repeated twice. Right? So x minus 1 and x minus 1. I have x minus 1 of 2 times. So in this case, the division of this rational function into the many rational functions will be different. Okay? So 4x divided to the x minus 1 in the square multiplied as x plus 1 is written as a divided to the x plus 1 plus b divided to the x minus 1 plus c divided to the x minus 1 in the square. Okay? So if you have one of the factors are repeated 2 times or 3 times, then you need to have such a number of the terms on the right-hand side part. Okay? For example, if I would have x minus 1 in the cube, how many terms you would have for this x minus 1 in the cube? 3 terms, right? It would be a divided to the x minus 1, b divided to the x minus 1 in the square, plus c divided to the x minus 1 in the cube. Okay? Do you understand the... This is like this. So for example, if you would have 4x divided to the x minus 1 in the cube plus multiplied as x minus 1 in the square, then you need to write this. Okay, so a divided to the x plus 1 plus b divided to the x plus 1 in the square plus c divided to the x minus 1 plus d divided to the x minus 1 in the square plus e divided to the x minus 1 in the cube. Do you understand the system, how it works? This is the steps what you need to do. So before, if this is not repeated like this, then you need to write a divided to the x plus 1 plus b divided to the x minus 1, right? Now, if one of the factors or several factors are repeated, then you need to write more terms on the right-hand side, okay? So you need to write a divided to the x plus 1 plus b divided to the x plus 1 in the square plus c divided to the x minus 1 plus d divided to the x minus 1 in the square, okay? So let's find a, b, and c, and we can try to add them, and you will see that we can find a, b, and c so that the denominator will be equal to the 4x, okay? So if one of the factors are repeated twice, for example, then you need to have 2 terms for this x minus 1, okay? So let's find a, b, and c. So how do we need to find a, b, and c? So what is our common denominator? This is the common denominator, right? So what I need to multiply the first term in order to have this? X minus 1 in the square, right? What I need to multiply the second term in order to have this common denominator? X plus 1 and x minus 1. What I need to multiply for the third term? X plus 1. Right? So let's multiply all the terms and find a, b, and c. Where? Which one? Which? Second? Yeah. Okay, second. The right side. Okay. Denominators of all the ratios. This one? Yeah. Okay. So let's multiply x plus 1 to the numerator. Don't take the denominators now, please. Only the denominators. Really. Because if we multiply them, we should get the left-hand side. I'm not multiplying. I'm getting the common denominator. So the idea is like this. So I will quickly explain you. For example, let's say you've got 1 over 5 plus 1 over 25. What is the common denominator? 25, right? This is not 125, okay? You know what I mean? Common denominator is, in this case, is 25, just 25, not 125. You don't need to multiply them in order to find the common denominator. I mean, of course, you can take this as 125 as well, but this is not necessary, right? You know what I mean? Yes? So the smallest possible common denominator, okay? The smallest possible common denominator will be x minus 1 in a square, multiplied as x plus 1, okay? You don't need to multiply all the denominators. You know what I mean? So here as well. So you don't need to multiply 5 to the 25 in order to add these two ratios. The common denominator here might be just 25, right? Okay. The same as here. Good? So let me multiply. So this is the different example. So let me multiply these three terms, okay? So a multiplied to z, x minus 1 in a square. What is x minus 1 in a square? X squared minus dx plus 1 plus b multiplied to the x squared minus 1 plus c multiplied to the x plus 1, right? So what I need to do is I need to write this as the polynomial, right? So let me regroup all the terms with the x squared. Where I have the x squared? Here and here. What is the coefficient in front of the first x squared? A. What is the coefficient in front of the second? B, right? Let me find the x. So I have the x here and here, right? So what is the coefficient in front of the first x? Minus dA, right? Minus dA. And what is the coefficient in front of the last one? Plus c. And what are the three coefficients? Plus a, right? Minus b, plus c. This is the free coefficient, right? So this should be equal to what? To the 4x, right? Do you remember? So this numerator should be equal to the 4x. Now, if you give the common denominator to the three terms, you will have on the numerator this term, and the denominator will be x minus 1 in the square multiplied as x plus 1. Okay? So if you would like to equalize them, you need to equalize the numerator on the left-hand side to the denominator, to the numerator on the right-hand side. Right? So basically, you need to compare the coefficients of the two polynomials. Okay? So what is the coefficient in front of the x squared on the left-hand side? What is the coefficient in front of the x squared on the left-hand side? 0, right? There is no x squared, so that is why the coefficient is simply 0. What is the coefficient before the x squared on the right-hand side? A plus b. Right? Do you understand what we're doing? Okay. So what is the coefficient in front of the x on the left-hand side? 4. On the right-hand side? Minus dA plus c. So what is the coefficient in front of the, like a free coefficient on the left-hand side? 0. There is no free coefficient. On the right-hand side? A minus b plus c, right? Again, I've got three equations, three unknowns. By finding a, b, and c, I can integrate this function, okay? I can split this rational function into the many. So let me find a from the first equation and put this to the second and the third, okay? So a is equal to the minus b. Let me put this to the second equation. So 4 is equal to minus t multiplied to the minus b plus c, right? So a is minus b plus c is equal to the 0, right? So the second equation gives me 4 is equal to the 2b plus c. The third equation gives me c is equal to the 2b. Right? The third equation gives me minus 2b plus c, which is equal to the 0, gives me c is equal to the 2b. So let me put the c is equal to the 2b to the second equation, and I will have 4 is equal to the 2b plus 2b. What is the b from here? 1, right? If you put this here to the third equation, what you get for the c? 2. If you put the b to the first equation here, what you get? Minus 1, right? So it appears 4x divided to the x minus 1 in the square multiplied to the x plus 1 can be written as minus 1 divided to the x plus 1 plus 1 divided to the x minus 1 plus 2 divided to the x minus 1 in the square. Okay? And please note that if you just add all of them, you will get exactly the rational function on the right. Okay? So do you know how to integrate them? So let's check it. So minus 1 over x plus 1. Its integration is minus ln of x plus 1. Right? So the integration of the 1 divided to the x minus 1 dx is ln of x minus 1. Right? So what is the integration of the t? 1 over x minus 1 in the square dx. So you need to take it as like analogously, like 1 over x squared dx. Okay? So what is this integration? X minus t plus 1 divided to the minus t plus 1, or simply minus 1 over x. Right? The integration of the 1 over x squared is minus 1 over x. So this coefficient is like nothing, because you can substitute this with some new variable u, right? Then the u will be simply dx. You know what I mean? If you take x minus 1 as the u, okay? What is the derivative of the x minus 1? What is the derivative of the x minus 1? 1, right? Dx. 1 dx, let's see. Okay, so this is equal to minus 1 over x minus 1. Sorry, minus 2. We have 2 here as well. Okay? Yes? Good. So do you understand what to do in the cases where the linear factors are repeated? Right? We need to add additional terms on the right-hand side part. So there is a third case. The third case is where, the case number 3, where the denominator cannot be splitted into the linear factors. Okay? So previously we could split the denominator to the linear factors because we could find the roots, right? Find a number so that this polynomial becomes equal to the 0. What happens if there is no root? Right? It means basically your parabola doesn't touch the line y is equal to the 0, for example, right? So let us consider this case. So if you're given tx squared minus x plus 4 divided to the x cubed plus 4x, right? Do you remember? So what we did before, step number 0? We need to check the powers, right? So degree of the numerator is 2, degree of the denominator is 3, right? I cannot divide them, so that is why I need to try to split the denominator into the linear factors, right? So this is tx squared minus x plus 4 divided to, if I take out the x from the bracket, it will be x squared plus 4, right? I cannot go further, right? So there is no root for this function, x squared plus 4. I cannot write this as a multiplication of the linear functions, right? Do you remember what we call as a linear function? Like kx plus b, right? Or ax plus b, right? So I cannot write as x squared plus b as a multiplication of the linear functions, right? So this is case 3, where the denominator cannot be splitted to the linear factors. In this case, so we are going to write this as a divided to the x plus x squared plus 4. And on the numerator, so do you see? So here, in the first term, I wrote the x, and on the numerator, I wrote the polynomial in the general form of degree 1 less than the denominator. Okay? So if the degree of the numerator is 1, then degree of the numerator should be equal to the 0, right? the general polynomial of degree 0 is the constant, right? Some constant multiplied as x in the power of 0, right? Okay, so if the numerator is the polynomial of degree 2 of power 2, then the numerator should be of the power 1, okay? So what is the general polynomial of power 1? Bx plus c, right? Bx plus c. Bx plus c, okay? So let's assume, so if you would have, so something divided to x multiplied as x4 plus 4. Then you would write a divided as x plus 1 over x, so x4 plus 4, right? Then on the numerator, you need to write a polynomial whose degree is 1 less than the denominator, right? So what is the degree of the denominator? It's 4. So what kind of polynomial I need to write on the numerator? Of degree 3, the cubic function, right? So this should be bx cubed plus cx squared plus dx plus e. Do you understand this? If this is irreducible, if the denominator is irreducible to the linear factors, then you need to write it like this, okay? On the numerator, there should be always the polynomial of 1 degree less than the denominator in general form, okay? That's it. So let's write tx squared. Let's go back to our example. So x multiplied as x squared plus 4 is equal to a divided to x plus bx plus c divided to x squared plus 4, right? Now I just need to give the common denominator on the left, on the right hand side, and find the a, b, and c, okay? So let me give the common denominator. What I need to multiply for the first term? X squared plus 4. What I need to multiply for the second term? Simply x, right? Okay. So if you multiply this, what you have? You will have a multiplied as x squared plus 4 plus bx squared plus cx, right? Divided to the x multiplied as x squared plus 4, right? So this rational function should be equal to this rational function, right? So the denominators are the same, and I need to equalize the numerators. So basically, tx squared minus x plus 4 should be equal to this denominator, this numerator, right? So let me take out the x squared from the brackets. Where do you have the x squared? You have the x squared here and here, right? What are the coefficients in front of the x squares? A and b, right? So there is only one term with the x, right, which is cx. And there is only one free coefficient, which is 4a, right? 4a, okay? So the polynomial on the right should be equal to the polynomial on the left. And these three polynomials are equal if and only if every single coefficient on the left is equal to every single coefficient on the right, okay? Corresponding coefficients should be equal. So t should be equal to the a plus b, right? Minus 1 is equal to the c. 4 is equal to the 4a, right? So what is the a? 1. What is the c? Minus 1. What is the b? 1. Okay? That's it. So x squared minus x plus 4 divided to the x squared plus 4 is equal to the 1 over x plus x minus 1 divided to the x squared plus 4. Okay? This is not the end of the story, because now in the third case, this integration will be slightly different. Okay? Slightly difficult, I would say. The integration of the last part. Once you split it, then you need to integrate this, right? Previously, all the time, we've got the ln because we could factorize the denominator to the linear factors, right? Now this is not the linear, and this will not be ln. Okay? So let's integrate this. So now I would like to integrate this one. So the integration of this one is equal to the integration of this one plus the integration of this one. Okay? So the integration of the first one is easy, so this will be ln of x. right? What about the integration of the second part? So this is the integration of x minus 1 divided as x squared plus 4 dx. Right? No, you cannot do this anymore, right? I mean, this is irreducible already, right? So you cannot write this as a t because like this is only one part. Do you remember previously if you have like a two parts, then you can write down. So if you have two parts on the denominators here, then you can write this as a t, right? But if you have only one part, you cannot write this as a t. Okay? Now we need to try to figure out how to integrate this. Do you have any ideas? Huh? Well, derivative? No. No. This is exactly like this. I mean, A, B, and C are correct. So we need to integrate this now. Okay? So in all these cases where you have case number 3, you will have this kind of integrals. Okay? Now we need to learn how to do this. Okay? So the idea is like this. So I'm going to split this integration into the two parts by dividing every single term on the numerator to the denominator. Okay? This will be integration of the x divided to the x squared plus 4 minus 1 divided to the x squared plus 4 dx. Right? Do you understand this? So what I did? So it's clear, right? I'm dividing the denominator to every single term, right? Then this integration splits to the two. The first part can be solved by introducing the substitution, right? So the integration of the x dx divided to the x squared plus 4 is equal. Now I need to introduce the substitution. Do you see that numerator is the derivative of the denominator, right? So u should be equal to the x squared plus 4. What is the du? To x dx, right? What about x dx then? Because I have x dx on the numerator. So du over 2, right? And what is x squared plus 4? Is u. So I substituted everything which depends on x with the u, right? So this integration will be ln of u divided to the 2 plus some constant, or simply ln of x squared plus 4 divided to the 2 plus the constant. Okay? The second part is a little bit tricky. The second part is the integration of dx divided to the x squared plus 4, right? If you would have here 1, then there is a formula, okay? The integration of the 1 over x squared plus 1 is equal to the arctangent of x, okay? Because do you remember the derivative of the arctangent was 1 over x squared plus 1, right? Okay, but I have 4. What I need to do? I need to get rid of I need to force to make this 4 to be equal to the 1. No. You need to make it 1. So let me take out the 4 from the brackets, okay? Let me write it like this. So dx, let me take out the 4 from the brackets. What you will have? X squared over 4 plus 1, right? So let me take out this. It will be 1 over 4 dx divided to the x squared divided to the 4 plus 1, okay? Now let's introduce the new variable, okay? So let me introduce. U is equal to the x over 2, okay? What is the du? So if the u is equal to the x over 2, what is the derivative of the x over 2? 1 over 2 multiplied to the dx, right? So, right? So let's substitute everything in this integral with the u, okay? So you will see why I'm doing this. So 1 over 4 integration. So what is dx? 2 du, right? So I can find the dx from here, right? If the du is equal to the 1 over 2 dx, then dx is equal to the 2 du, right? Divided to, what is x squared over 4? Is u squared, right? Because u is equal to x over 2, then x squared over 4 is u squared, plus 1, right? Now let me take out this t from the brackets, from the integration. It will be 1 over t, integration of the u divided to the u squared plus 1. What is this? Arctangent of u, right? So 1 over t, arctangent of u. Or this is 1 over t of the arctangent of x squared or x over t. Okay? So if you have the third case where the denominator is irreducible, then you need to deal with this integration, with the arctangent. Okay?